3.
Perfect. Here. Thank you so much.
Thank you. I'm very excited to be here because LED is one of our best performing regions for HeatWave, so very excited about the opportunity and thank you. So let me start off with what is HeatWave. HeatWave is a fully managed data processing service from Oracle, which is offered in multiple clouds, and it's only offered in the cloud. So this is an offering which was designed from the ground up at Oracle. It is not offered as an on-premise solution. It's only offered in the cloud. And the design premise of this was to build the world's most efficient data processing system. And when I say most efficient, in terms of price performance. So the HeatWave is an in-memory query processing engine. It has been designed to process data which is in the object store very efficiently. So if you have data in the OCA object store, if you have data in S3, if you have data in GCP object store, HeatWave is designed to process the data very efficiently because of scale-out properties, which I'm going to talk about. The second thing which HeatWave does is that if you have data in a MySQL database, it can process that also very efficiently. So we call it HeatWave MySQL or MySQL HeatWave because it adheres to the semantics of MySQL. So the cool thing with this is that there are millions of MySQL applications worldwide. You can take an existing MySQL application and you can run it on content which is stored in an object store. Not only that, as I'm going to show, it is very performant. In fact, it is the most performant data processing engine out there, and it is also the most price performing processing engine out there. And the data in the object store could be coming from a variety of scenarios. One of the scenarios which we see is that customers may have their transactional data in some database, let's say SQL Server or like Aurora. They keep their transactional data as is. They move that data from their source database to the object store, and then they use HeatWave for running analytics, for doing machine learning, for doing generative AI. Right? So if there's one thing you should take away is that HeatWave is available only in the cloud. It is designed to very efficiently process data from the object store. If you have data in MySQL, it processes that also very efficiently, but it's really designed for object store processing. So there are three design principles of HeatWave. Right? So HeatWave was a result of 10 years of research at Oracle. It has three design principles. The first design principle is that HeatWave is a massively partitioned architecture, much more than any other database. So when you have data, let's say from the object store in a MySQL, unlike traditional techniques, HeatWave loads the data from the object store to the memory of HeatWave using machine learning to figure out what's the right partitioning mechanism based on the queries and based on the data. Other databases don't do that. That's the first thing. Secondly, each of the partition fits in the cache of the underlying machine, which is why you get very, very good performance. Right? So each partition is sized so that it fits in the underlying cache, and that's why we only run it in the cloud, because we know which shapes we're going to be running on. And third, we invented new algorithms in our team so that we can process these partitions, whether it's joins, whether it's aggregates, at near memory bandwidth. So a lot of the performance you're going to see with HeatWave, including for vector processing, is at memory bandwidth, which no other database does. Right? So no other database does vector processing at memory bandwidth, but HeatWave does because of these properties. The second design goal or objective of HeatWave is not only do we do very good processing on a single node or a single processor, but HeatWave scales to a very large number of nodes. In fact, there is no other data processing system which can scale to that many number of nodes. So a single instance of HeatWave can span 512 VMs or 512 servers. And when you do that, the scale factor is close to 0.9. So what happens is, you're doing very efficient processing on one node, you process very efficiently across 500 nodes. That's how you get very good performance and very good price performance. And the last aspect is, right from data loading to data partitioning to indexing to even coming up with the query plans, we use machine learning internally very extensively to determine, for instance, what should be the partitioning key. Not only that, when the query optimizer runs, it looks at the execution plans of the previous queries to make the execution plans even better. So one of the very interesting properties of HeatWave is that as you run more queries, the system gets faster. So that's a very interesting property. So it's a result of these three principles. Many of the things I'm going to show you why the performance is good or why the price performance is good is based on these three things. Very efficient in-memory processing, very efficient scalability, and machine learning to automate the query processing. So 5 reasons why customers choose HeatWave. First, HeatWave provides the best performance and the price performance in the industry across any benchmark which third parties have evaluated. Snowflake, Databricks, BigQuery, Aurora, Redshift, you name it, right? And by at least an order of magnitude. Right? So that's the first thing. So when you're running a workload in the cloud, the thing which really matters is price performance, and HeatWave offers by far over an order of magnitude better price performance advantage over any other database we have compared with for SQL processing. The second thing is you can have this data be in the object store. And the amount of data we are talking the object store can be hundreds of terabytes, and very soon we'll be scaling to petabytes of data in a single instance. Right? So when your data is in the object store, we provide the same level of performance as when the data is inside the database. Typically people store their data inside a database because they want good performance, but people store the data in a file system because of flexibility. With HeatWave, you get the flexibility of a file system, but you get the performance of a database, which is quite novel. Third is, if you have MySQL workloads, HeatWave is the best platform because we run the enterprise edition of MySQL for one, and we have enhanced MySQL in many ways for cloud-only features. One example is the autopilot. So using HeatWave, if you have MySQL workloads, the system automatically makes recommendations for what kind of indexes to create. It has this notion of auto-thread pooling. These are only available in our cloud service and across multiple clouds. Third, we have built-in generative AI in vector store. And when I say built-in, HeatWave is the only database in the world which offers in-database LLMs, which runs on CPUs. No one else does that. So sure, we can invoke LLM models running on GPUs, but if customers want to run inside HeatWave, want to run on their existing instance, if they want to run on CPUs, because of cost, availability, they can do that, right? And no other database does that, and that's one of the reasons why the generative AI with HeatWave has been, has had a very good and fast uptake. And finally, HeatWave is available on multiple clouds. Surely HeatWave runs on OCI, provides very good performance and price performance, but HeatWave for the last 3 years has also been running natively inside AWS. So the data plane, control plane, console, they all run inside AWS. We also support Azure, and now we are working towards supporting HeatWave on GCP. So I'll elaborate on each of these points a little further. I won't go through each of these numbers, but just to give you a perspective, right? When I say that we are the fastest database, that's fastest being one thing, but we are also the least expensive, and which is why you can see across the board, we have better price performance compared to Snowflake, compared to Databricks, compared to Redshift, compared to BigQuery, compared to Aurora. Right? And these are things which a third party has run. All the scripts, all the benchmark results are available on the website, which you can take a look at what configuration, and the scripts are available for you to download, maybe change them and see how it performs for your workloads. The data in the data lake is growing because data lake provides the least expensive form of storage, the most durable form of storage, and the most scalable form of storage. And what we do with HeatWave is to do very efficient processing. And when I say processing, I'm talking about SQL processing, I'm talking vector store processing. So one of the key things, and we'll get into the details, is that HeatWave takes data, unstructured content, which is in the data lake, creates a vector store, and then can do vector processing on data residing in the object store. Not transactional in nature. Customers typically prefer the object store. But if your data is transactional in nature, instead of developing our own database, we leverage MySQL. And that's why we have MySQL. And that's one of the reasons we call it Lakehouse. It's a combination of data lake and database. Right? So you can just query data on the data lake. You can just query data in MySQL. Or if you have data spread between these two, in a single query, the query can cut across between data lake and the MySQL database. Now, there are many vendors across the globe who offer a managed service for MySQL. But the thing to note about HeatWave is the only one which takes the enterprise edition of MySQL and offers that as a managed service, right? And MySQL is owned by Oracle, it's in my team. So it's the same team which is building MySQL, which is offering this as a managed service. Plus, we have added a whole bunch of new cloud-only enhancements to MySQL. Auto indexing is one, auto shape prediction is another one, support for JavaScript, and there are many other things. Like we have a new optimizer which we just released. All of these are available only in the cloud version of MySQL as a part of HeatWave. It's both for machine learning and particularly so for generative AI. A lot of enterprises want to leverage generative AI, but the issue is that it is very hard to hire or employ data scientists, and it's very expensive to do so. So one of the goals we have had is to really make the out-of-the-box experience very, very simple for customers so that they don't need AI expertise or they don't need to provision too much of data, too many of the services. So out of the box, we have a couple of LLMs. We have support for Mistral, we have support for Llama 3 inside the database. So what that means is that any instance of HeatWave is now a chatbot, and we support 47 languages, right? So whether it's Spanish, whether it's Portuguese. So anytime you create an instance of HeatWave, you can actually start having a conversation with your instance because we have in-database LLMs available at no charge and without having to worry about requiring GPUs or some other service. The second aspect is availability. Since we run inside the database, regardless of where you're running this instance, it could be in a public cloud, it could be in a private cloud, or dedicated region. Wherever HeatWave runs in OCI or in some other cloud, you can get the same semantics with HeatWave Generative AI. Performance in the industry, both for creating a vector, which is very time consuming, as well as for doing similarity search. And finally, the reason people prefer HeatWave is multi-cloud. So HeatWave was one of the first services from Oracle, which was offered natively inside AWS. We have been in OCI from the beginning, but we introduced HeatWave support natively inside AWS like fairly early on. And here's the main reason. We had the maximum number of customers migrating from AWS to OCI to run HeatWave, right? So a lot of the customers, in fact, majority of the customers who are coming to us for running using HeatWave, these are customers who are migrating from AWS. However, there's a class of customers who cannot migrate because they have so much of data and AWS charges you very high egress fees. So to accommodate those customers, we now run HeatWave inside AWS. And what we find is in many of the cases when customers have transactional data, they don't want to touch the transactional data with Aurora. And they replicate the data to HeatWave and do processing. We also have HeatWave running with Azure, and finally we are working on HeatWave for GCP. Now, I'll start talking about a little bit of details on each of these components, but before I do that, are there any questions?
If I understood it right,
it can be semi-structured data represented as a JSON, or it can be unstructured documents like PDF, PPT, right? Various like document formats. Data in the object store remains in the object store. So we do not copy data from the object store to MySQL or to inside HeatWave. HeatWave is an in-memory engine. We read the data into HeatWave and we copy the data or write the data back to the object store. And then you can have existing tools and applications run. We have not changed the semantics or syntax of MySQL at all. So that's one of the big selling points over here, right? Unlike say BigQuery, where they have added proprietary syntax, over here we are adhering to the syntax of MySQL. So existing tools and applications, they just work. So we didn't have to do much work, for instance, to integrate with Tableau or Looker, because they all support MySQL, and that's a syntax which we support. Now this is the performance I was talking about. This is just showing the performance. It was done by a third party on half a petabyte of data, right? So a single instance running half a petabyte, you can see HeatWave is anywhere from like about 10 times faster to like 35 times faster. Ballpark, compared to Databricks and Snowflake, it's about 15 times faster and 35 times faster than BigQuery on half a petabyte of data. And this is a standard workload, like PPCH. This third party didn't make up their own. This is a standard workload. Now the question is, okay, this is performant, but how about the price? Because if the price is too high, then it's not a very fair comparison. And this is the price performance. So performance, we were 10 to 35 times faster. Similarly, when you look at the price performance, we are anywhere from 8 to 30 times faster. And the most of the times, the questions which you get are actually Databricks, Snowflake, and BigQuery. We don't see much of Redshift anymore these days. But when you are offering 20 times better price performance, it means if you're spending 100 units of dollars on Snowflake, you just spend $5 with HeatWave or with OCI. All the results and the scripts are available over here. All the scripts for these benchmarks, which were done by the third party, are available on GitHub. We have a lot of customers who are migrating to HeatWave, and there are two interesting things I want to point out. A, there are customers who are migrating their data from other databases, SQL Server, Teradata, DB2, SAP HANA, right? So many customers migrating from other databases to HeatWave because of the value proposition. Secondly, we have customers who are migrating to OCI to leverage the benefits of HeatWave. Right? Because keep in mind that although HeatWave is offered in multiple clouds, since OCI is our platform, when we run on our hardware, we get the best price, obviously, right? So although we offer multiple platforms, customers get the best price performance with HeatWave on OCI. So many customers migrating to OCI to leverage the benefits of HeatWave. The second aspect, which is actually very interesting, is that since the performance of HeatWave is so much faster than the existing databases, like say an order of magnitude and such, it enables new class of applications. So one of the domains which is going to be very popular with HeatWave are the telco, because that's a lot of like CDR data, which customers want to store inexpensively on the data lake and then process it. But otherwise for digital marketing, gaming, healthcare, food tech, like take the case of fraud detection. Given that HeatWave provides in-database machine learning, which is very efficient, customers are now able to do things in real time, which they were doing earlier as batch processing. So if you have needs, if you have use cases in any of these domains, we can give you references, we can give you some pointers as to how other customers have been using it. Now, one point, which in case it's not clear, is that HeatWave does transaction processing, analytics, machine learning, generative AI, vector processing, data lake, all inside one service. In contrast, if you were to deploy something on AWS, you will have to use about 5 to 6 services. When you have so many services, there is data complexity, there is more cost, performance is not as good, but just think about the exposure from a security standpoint. Because each time you connect to a different service, you have to authenticate with some credentials. With HeatWave, the data and the processing is all inside HeatWave, so that makes your applications more secure. Now let me, okay, so I talked about analytics, now let me talk about there are two areas of research. As I said, HeatWave came as a result of research we did at Oracle. There were two areas of research we did. One was on the database side, the database research. The second thing was on machine learning. So what we have done with machine learning is to fully automate the process of creating a model, which means that if you have a task, like you want to do classification or anomaly detection, and you have some data set, the system automatically determines which is the best algorithm, which are the best set of features to use, and what are the best hyperparameters. This is something which is done automatically inside the database for you. In addition to that, for all the models which are created, the system automatically generates model explainers. So if the system is making a recommendation, you can go and ask it, okay, why was this recommendation made? If someone's credit card was denied, you can go and say, okay, why was the person's credit card denied? And the system will give you an output saying, you know what? It was because maybe the person's income was low, or maybe like, earlier their credit score was low, right? So it gives you like a weighted ranking as to what were the factors which were used to make a recommendation. And this is something we feel is very important for enterprise workloads. We have customers in a lot of these different domains who are using machine learning. In fact, we do have customers who have migrated from, like, say, GCP to HeatWave. In fact, as I said, like LA is one of our best performing regions, and like S2 Love, right? They migrated from GCP. They were only using BigQuery to HeatWave, to OCI, primarily because of the machine learning capabilities, right? So we do have customers who find the machine learning aspects of HeatWave to be compelling enough to migrate to HeatWave. So these are the 5 tasks we support: classification, regression, anomaly detection, time series forecasting, recommender systems. Now the thing is, in some cases, we have taken open source algorithms and we've enhanced them. But in some cases, we have our own IP, like anomaly detection. We have our own algorithms. Recommender systems, we have our own algorithms, which the system obviously makes a cost-based decision. In most of the times, you find that it outperforms what the other algorithms are. Now, doing training inside the database, having explanations inside the database is definitely easy. It automates things. But one of the aspects is when the training is usually the long pole. And again, this was done by a third party comparing the performance of training of HeatWave with Redshift ML, which in turn invokes SageMaker. HeatWave training is about 25 times faster than SageMaker. Now, sure, if it's faster, it makes the results come sooner, that's okay. But one of the aspects to understand, if the training is so much faster, it means your models can be kept up to date sooner. If they can be kept up to date more frequently, it means that the prediction the models are going to make is going to be more accurate. So faster training often results in more accurate predictions or inferences, right? Because you can keep the models up to date more frequently. And there is no cost for machine learning running inside HeatWave. But if you were to provision a cluster just to run machine learning with HeatWave, even then, it is just 1% of the cost of Redshift. Now moving to generative AI. We introduced generative AI in about July. There are 4 specific things which we provide. The first is in database and fully automated vector store. So vector store is where we take unstructured content and we create a vector out of it so that then you can do similarity search or you can do vector processing. So it's in database, and by automated, I mean you don't need to provide any embedding model, you don't need to provide any ability to run, it just runs inside HeatWave. That's the first thing. The second thing is we provide, in addition to being able to invoke external LLMs, we have in-database LLMs, right? So we support Mistral and we support Llama 3. And with that, you can do generation, you can do RAG, you can do the usual stuff which you can do with GenAI. Second thing. Third thing is the vector processing, which is in-memory speed and scales out. So when I was talking about how HeatWave vector processing is about an order of magnitude faster than Snowflake or Databricks, that's with a single node of HeatWave. If you want to make it even faster, you can just add more nodes and it keeps scaling out. And finally, we provide an out-of-the-box, like a UI, which we call HeatWave Chat. It's actually a VS Code plugin, and that provides a very interesting interface by which you can interact with both your structured content as well as unstructured content. Since we went GA with HeatWave GenAI in July, there have been a lot of customers in various domains who have been uptaking HeatWave GenAI. 2 interesting observations. One is LED. LED has been the fastest in terms of the adoption. In fact, many of the examples I have are from customers in LED who are using HeatWave GenAI. The second thing is internally, since then, we are using now HeatWave GenAI. So for instance, like support for MySQL and HeatWave, that uses HeatWave GenAI to make recommendation to the analyst to say if there's a bug or a service request which comes in. It looks at existing documents and makes the first pass recommendation, which makes it much easier or efficient for the support engineer to triage the issue. Secondly, starting this month, all the documentation which we are now releasing for MySQL and HeatWave, that is being generated by HeatWave GenAI. That is something which makes the life in the process more efficient. But now what is very interesting is that in the past, our documentation was only in English. Now that we are using HeatWave GenAI, we will be providing our documentation in multiple languages because this translation can be done by the GenAI models. So this is the HeatWave Chat. It's a VS Code plugin for MySQL Shell. So in case someone has been using MySQL, they're away with MySQL Shell. But we have taken MySQL Shell, which is already able to process and manage data inside MySQL, and extended that in 2 ways. A, extend it to understand and support the OCR object store. So if there are files in the object store, you can now view them and navigate them through this interface. And the second thing is now you can start, you have a prompt for interacting in natural language. Both Portuguese as well as Spanish are supported. In addition to this, you can do pretty fancy things like doing folder restricted search. So if you want to ask a question, but you don't want to ask all the corpus of documents, but you just want to ask it in one specific folder, these are things which now you can do. One of the reasons I feel there has been such a fast uptake of HeatWave GenAI is because we have made it very simple to use for customers. So when you want to use generative AI, there are really 2 things you do. Right? One is you create the vector, and the second thing is you use the vector using an LLM, or you can use similarity search as well. typically there are 9 steps to create a vector, from identifying which embedding model to use. You have to figure out which parser is going to support the kind of document or the unstructured content you have. We have replaced those steps by a single command, and this is the same command we use to load structured data, semi-structured data, or to create a vector store. And what you can see is that there is no AI specific angle over here. All it says is just specify the location of the document and just tell me where you want this vector store to be created, and just does it for you automatically. Similarly, when you want to invoke the LLM or the vector store, you invoke MLRAG. You can do similarly ML generate or whatever you like. You ask this question, and the answer goes to the response. Now, if you are an expert and you know how to do a better job with the prompt and such, we do provide option search parameters where you can augment the prompt or provide like more specific information. But at least to get started, that is not required. In addition to making it easy, the benefit of doing all of this processing of creating the vector inside the database is that we can automatically parse it for you, but we can also automatically parallelize it for you across various cores and across the various nodes. So what it does is that it uses the resources much more efficiently, which then reduces the cost for you. Right? So I'm not aware of anyone else who is able to parse, segment, and do encoding across cores and across the nodes. And we do it automatically for you. You just say, hey, HeatWave load, and it does this thing automatically for you. So we did a comparison with the knowledge base for AWS Bedrock. The y-axis is in hours. So what you can see is that by just using 20 nodes of HeatWave, and we have all the way to go to 500 nodes, just by using 20 nodes of HeatWave, it's about anywhere from 10 to 30 times faster for various document types compared to AWS Bedrock. And it is 1/4 the cost. So 1/4 the cost and up to 30 times faster for creation of the vector store. So earlier, things which were taking, like say 10 hours for HTML documents, the creation can be done in less than an hour. What is interesting is, okay, you've created the vector, but that typically you do once, and it's incrementally updated, by the way. So as your documents change, we keep the vector updated automatically for you. But now the interesting thing is, how about the query processing or the similarity search? This is a comparison done by a third party. They took a whole variety of queries, and you can see the price performance of HeatWave compared to Snowflake, Databricks, and BigQuery. It's anywhere from 40 times better to 100 times better for vector processing. And it all comes down to the initial 2 slides I was showing you. It is done at near memory bandwidth, the processing, and as you add more and more nodes, the performance of the system scales almost linearly. So not just the performance of HeatWave is so much better for vector processing, but even the cost benefits are so pronounced. I mentioned about the in-database LLMs. So one thing is security. Your data and the processing is always inside. You don't need to provision something externally, so it reduces the cost for you. And the third aspect is, regardless of where you're running your application with HeatWave GenAI, you will get exactly the same results because you're using exactly the same models with the same number of parameters, same level of quantization. Obviously, if you do want to use a GenAI service, which will give you faster results for LLM invocation, you are welcome to do so. And this is one of the important points from a multi-cloud perspective, right? Because we want to make sure that our customers using HeatWave, whether they're running on OCI or AWS or Azure, they get exactly the same results. So with the in-database LLMs, since we have the same number of parameters, same level of quantization, your applications will get exactly the same results regardless of where it is, and it significantly improves the availability of being able to use GenAI. Because wherever HeatWave is available, which is like close to 100 regions by now, HeatWave GenAI is available. I want to walk you through some use cases. So this is an example actually of NVIDIA. So what is interesting is NVIDIA uses HeatWave AutoML for doing anomaly detection on their logs. And that's something they've been doing for some time. In fact, about 2 cloud worlds back, they even came on the stage to talk about this use case. What they do is they take the logs which are being generated from their testing system. They use HeatWave AutoML to determine where the anomalies are. What is now interesting is that they're trying to integrate that with HeatWave GenAI, so they have all the Jira tickets, collateral, the bug database. And they want to take the error messages, for instance, which are being generated in the log, and then summarize what that issue is. So anomaly detection itself is useful because now they can know from millions of logs which are the ones which have issues. That's already out in production at NVIDIA. But now the POC is with GenAI to see that, okay, can they reduce the operator effort to figure out what went wrong? The second use case is this company called ETZ. They are the Uber Eats equivalent in the Middle East. And they were running a combination of Aurora and Redshift on AWS for the delivery services. This is one example of a customer who migrated from AWS to OCI because of the ML capabilities of HeatWave. Sure, they found other benefits in terms of cost, but the main reason they migrated is because of AutoML. And what they do already in production is that they use HeatWave AutoML to predict how long will it take for a driver to deliver that specific food item to the customer. So as opposed to offering a static SLA, it is a dynamic SLA based on the kind of food, the kind of restaurant, the traffic, the time of day and such. In addition to that, now what they're working on with generative AI is that when the system makes a recommendation that, you know what, based on the kind of previous orders the guy has ordered, right? Like whether it's they're more into fast food or more into like salads and such, the system also looks at the menus which are available in public domain and makes a specific recommendation that, you know what, this person is vegetarian and he likes tofu, and you know this restaurant is having a good deal on it, and we feel that this is the place where the person is most likely going to order from. They believe this is something that can be very, very differentiated for them in the industry because no one else does that. So that's a second use case. Using this, they offer online courses. And in the past, they've been using text indexes and such for like having customers come on their site and look for courses. What they told us is the fact that we had this HeatWave chat made it very easy for them to get started. What they found within 1 month of trying this is that the number of hits they were getting were much more than in the past. And they were like, hey, why is that happening? And the reason that's happening is that now with vector search, the system does similarity search as opposed to an exact match with text-based processing. So for instance, if the course says introduction to OCI or first time users of OCI, that will translate very well. So if someone is searching for beginner level courses on OCI, it will result in a match, which was not the case earlier. In addition to that, they can combine the similarity search with other predicates. If you want to say, okay, I want this course which is being offered just on Tuesdays and Thursdays during this time of day. Vector databases cannot do that, but HeatWave can. They're providing a very interesting service using HeatWave. They have their customers upload their content, their proprietary enterprise content, which then they use HeatWave to query and provide results on in multiple languages. So if you're like e-commerce or fintech, you load some documents. Now optionally, you could also have some proprietary documents, right, or some data which you have kind of bought, and you can combine this data with some other data which Socobox provides. But the main thing is it provides out of the box a chat box experience without requiring any external tool, any external hardware, any external service. This is all available out of the box with HeatWave. Right, whether it's in database LLMs, vector store, AutoML, and such, JavaScript. Performance is also the same. The only nuance is, like as I was saying, for vector creation, HeatWave is 1/4 of the cost of AWS Bedrock. If you're running inside AWS, obviously the hardware cost is a little higher. So instead of it being 1/4 of the cost, HeatWave running inside AWS is 1/3 of the cost of AWS Bedrock. Now and this is about the transaction processing. So how many of you over here like use MySQL or your enterprises run MySQL? Okay. So you're familiar with two versions of MySQL. There's an open source version of MySQL, there's an enterprise edition of MySQL. The enterprise edition has features and capabilities like security features, enterprise backup and such.
Excuse me, is it possible if I have a Oracle database?
So what's your question? If you have Oracle database, can you attach HeatWave? Is that your question? No, you can't do that. So over here, you can process data from the object store, or you can process data inside MySQL. So if you have the Oracle database, then you're better off using Autonomous, right? Because that provides very good capabilities.
No standard.
Sorry?
Oracle database standard is not in the model of, is no other object store.
Correct. HeatWave cannot process data from inside the Oracle database, unless you happen to export the data from an Oracle database to an object store. That's a different thing. And there are customers who use Golden Gate to maybe move some data from Oracle to say MySQL or to object store. But apart from that, you can't just plug in HeatWave. You will need to use something like Golden Gate service to move data.
So both databases have this capability of reading Parquet files from object storage, obviously with different architectures, both autonomous and HeatWave.
So if you have, as I said, right, if you have the data in the Oracle database, your best option is to use autonomous, right? Because you don't need to change the application. Because the other thing is this, right? A lot of effort is spent in changing the semantics, right? So MySQL is sure a standard, right? But it has different semantics than Oracle. So if you already are using Oracle database, you're just better off using autonomous. So now when it comes to transaction processing, that's the capability only offered on data which is inside a transaction store, which is MySQL, right? So we do not, or we cannot offer transaction processing on data in the object store, right? So only the OLTP aspect is the one which we offer with the MySQL database. So the first thing is, just the way I talked about other capabilities, we have made a lot of cloud-specific enhancements to MySQL. And running MySQL with HeatWave provides better performance and lower cost compared to any other MySQL-based service, right? So these are numbers from RDS MySQL, Azure MySQL, and such. Now the mileage may vary, but HeatWave will provide you the best performance and the best price performance compared to any other MySQL-based service. Plus, it runs the enterprise edition of MySQL. Plus, we'll talk about some of the other capabilities it has. One example of that is Autopilot, which uses machine learning-based automation. So what it does is, if you have a lot of connections coming in, if you have a lot of requests coming in, we have a mechanism by which we determine that, you know what, the rate of incoming transactions is so much that we want to not process any more transactions because it can lead to a drop in throughput. And because of that, with HeatWave, for your MySQL processing, your throughput never goes down. If you were to run the same workload in Aurora, this is the drop you're going to see because the system doesn't have this autopilot capability. The other example which we have is autopilot indexing. This is something which we recently introduced. Here, the system makes a recommendation that for your workload, whether you're going to be better off creating some indexes, dropping some indexes, and furthermore, it tells you what is the benefit you're going to get by creating an index or dropping the index. So not only does it make a recommendation, it quantifies the benefit for you so that you can take the appropriate action. HeatWave runs natively inside AWS on AWS gear. But you don't pay for AWS gear, you just pay, like, HeatWave, we provide a fully managed service. So we provision the AWS gear for you. We provide all the capabilities which I talked about on OCI inside AWS as well. And AWS, you can just have one service with HeatWave on AWS. So to summarize, HeatWave processing of data residing either in the object store or inside the MySQL database. It provides the best performance and best price performance in the industry for
grid search or hyperparameter tuning, and how HeatWave
in trading, hyperparameter tuning is the most expensive way, right? It's the most expensive step. So what we have is, as I was telling you, we have some IP. And one IP we have is for hyperparameter tuning. So the way the hyperparameter tuning works is that you're looking for like a whole bunch of parameters where the right values are. What we have invented is a new algorithm which starts off the search, but it proves the search much sooner, right? So that we don't look at parts of the trees which are not necessary. That's just one way of doing it. And the second thing is, when you have parallelism, one issue is synchronization. So we have parallelism by limiting the amount of synchronization we have. So we have some of these techniques which make it faster. That's the first part, right? And that's automated. Now, while it is automated, we do provide the flexibility that if you're a data scientist, and exactly to the point which you said, that you want to have a trade-off, that you know what, I want to optimize for time as opposed to the accuracy. Or I really know that this is the model I want to use. You can absolutely specify them as an option parameter. In fact, you can also import your own models inside the database as long as they're in an ONX format.
Which format?
ONX.
ONX
ONXX,
format.
yeah.
Oh, okay.
This is a secure, serialized format. So
Okay, perfect, thank you.
whatever it is, right? And when they move the data to HeatWave or to the object store for doing analytics, for doing machine learning, for which the standards aren't that clear, and we support most of the standards for the analytic operators. That's typically what we see.
Oh, then it's just for back office duties, not just for the.
Well, a lot of the anomaly detection or the AutoML or GenAI, that is also for the front office, that's one. And we see a lot of the customers migrating from MySQL compatible workloads. Right? That's a place where we see a lot of the existing applications migrating, if it's a MySQL compatible. But if your data is in the object store, then you're debating between Snowflake, Databricks, BigQuery, right? And for all of them, you will have to write new workloads or new applications. And that's the time to think about HeatWave.
And what's because
So Autonomous is taking the Oracle database and offering it as a fully managed service, right? With a lot of similar capabilities, a lot of automation, a lot of machine learning and such. HeatWave is designed for two things. A, data in the object store, or B, if you have data in MySQL. That's the difference.
that's the okay.
And but in both of the cases, there's a lot of very good innovation, but yeah, that's a distinction.
Good. Congratulations. That was.
Thank you.
Okay, then.
When it decides, right? Sometimes what can happen is you may have some construct, like, nested subqueries is one, where there may be some difficulty in offloading the query to HeatWave. That's the most common thing, but we have not seen scenarios where customers say, hey, my query is running fine on say 10 terabytes of data, and when I'm going to 100 terabytes, there's a problem. That usually does not happen. What may happen is when you, in fact, to the question the gentleman asked, that you are migrating from some other database, you have some syntax, you try to run the same syntax, and that can give you suboptimal performance. And there we have tuning tips to say, no, you know what, use this. And that way HeatWave will understand it better.
Got it.
All right, thank you.
Nipun, thank you so much.
3, 2, 1. One more time.